Welcome to the CDNetworks Tech Chat. Today we'll cover CDN basics. If you have any questions, submit them via the chat box and I'll answer them at the end of the presentation. In the next 5 minutes or so, we'll go over the Internet, the challenges of fast, reliable content, and how a CDN can help you achieve these goals. As background, the Internet is a collection of private networks that are interconnected with each other. Everything from big global Internet service providers, ISPs, like AT&T and Level 3, to regional and local ISPs. They all interconnect with each other and must speak the same language for content requests to traverse them. In most cases, content requests travel across multiple ISPs. One of the biggest hurdles to great performance is distance. The further you are from content, the longer it takes to see it. You have to make a request, then wait for the response. You can see the different response times between cities that are close versus those that are far away. The second hurdle is reliability. There's so much traffic that sometimes a packet gets lost or is dropped. This can happen at any point during send or receive. The web browser automatically notices this and requests it to be resent. This works, but can cause slowness. And third is that HTTP, what we all use to communicate over the Internet, is very chatty. There's a connection phase to ensure both sides are ready. Then the file is transmitted, which takes multiple round trips, and then the disconnection phase happens. The original designers created a very robust network that could survive multiple failures, but doesn't efficiently take advantage of today's better performing networks. CDNs were designed to overcome all three of these challenges. A CDN should have over 100 POPs, points of presence, or data centers geographically distributed around the globe. And inside each POP are hundreds to thousands of servers. These POPs and servers are used to globally accelerate content. As background, there's two types of content, static and dynamic. On the Twitter page, the Twitter logo and graphics are static. They rarely change, and we all see the same images. The Twitter feed, that's different for each of us. That's dynamic. It's always changing. And here's a representation of how a web page works without a CDN. The end user requests the home page, which results in individual requests to retrieve the logo image, the HTML, as well as big files and any dynamic content. This works just fine, but can be slow. And here's how a CDN will accelerate static content, for example, the Twitter image we just talked about. The CDN caches all of the static files locally in their POPs, so when end users request the web page, it comes down fast because it's close. If the CDN doesn't have a file or a new one is requested, it's grabbed from the origin as needed. For dynamic content, CDNs use a different approach. The CDNs that support dynamic content create a superhighway to accelerate across the long distance, which is something that individual ISPs can't do. There's a lot of different dynamic acceleration techniques that CDNs use, and we're doing a future 6-minute webinar on dynamic acceleration, and we'll go into specifics. And finally, a CDN should protect itself and help you protect your origin. There are hackers trying to take down websites every day, and CDNs can help protect against that threat.
In summary, CDNs were specifically designed to improve the performance, reliability, and security of Internet content. Here's a typical example of an origin in a single data center with response times in orange at the top. In the middle, in blue, are response times for 3 data centers using cloud hosting or co-location. And the performance and reliability of a CDN that supports both dynamic and static acceleration is in yellow at the bottom.